Solution to question number 10, part D, is a bit of a tricky question. It says, find the constants m and b for which y equals mx plus b is the solution to the differential equation. So the differential equation is 2x minus y. So we have to remember that the differential equation gives us slope. So dy by dx is equal to 2x minus y. And that's equal to slope. But we also have to remember that this is the solution to the differential equation. So y equals mx plus b, this represents the output when the input is x. So what we can also do is we can replace the y here with mx plus b and any y in any parts of the equation. Okay, so first thing we're going to do is this. We're going to come up with the relationship that the differential equation is equal to m, the slope. The other thing is we can also substitute in the same expression the y expression, which is mx plus b, into that same expression. Okay, so I'm just going to highlight this. So mx plus b is going to be that y, which is what we've substituted here. Now, from here it's still not that easy because we need to solve for m and b. And we have an x in there that we have to worry about. So I'm just going to rearrange this a little bit. And I'm going to group my x terms together. And so I end up with negative b minus m equals 0. So at least I have it equal to 0. If I can find factors, I can solve this. Now this is not that easily factorable. In fact, when I factor this, I end up with 2 minus m, and just going to factor that, and b plus m equal to 0. Now this doesn't let us directly solve for this, but what we could say is that to solve this equation, the 2 minus m must be equal to 0, and b plus m must also be equal to 0. So I'm going to end up with this solution here. So again, the reasoning is that I need to make this equal to 0 independent of the x value. That means that this part must be equal to 0. So we end up with m equals 2, and also at the same time, this must also be equal to 0 at the same time. So we know that b is equal to negative m. Well, we know that m must be equal to 2. That means that b must be equal to negative 2. So if those conditions are met, this solution is equal to 0, which then satisfies our m and b for this situation.